Most welcome in calculus classes. Now we are starting chapter number 10. In this module, you will learn reflection of light, types of reflection, laws of reflection, spherical mirrors, image formation by spherical mirrors, mirror formula, and magnification. So we will start the chapter. So first topic of the chapter is light. Light, that means energy. Type of energy which is responsible for the perception of being. That means आप ऐसे समझ सकते हैं कि लाइट एक एनर्जी है और वो एनर्जी है जो हमारे परसेप्शन ऑफ बीइंग को के लिए रिस्पॉन्सिबल होती है. दैट मीन्स हम चीजों को देख पाते हैं तो जस्ट बिकॉज ऑफ लाइट. लाइट ऑब्जेक्ट से रिफ्लेक्ट होती है, देन इट एंटर्स इन आवर आईज एंड जस्ट बिकॉज ऑफ दिस रीजन वी आर एबल टू सी द ऑब्जेक्ट. Now we learn about the reflection. The reflection of light is the phenomenon of bouncing back of light in the same medium on striking the surface of any object. That means if light falls on the surface of any object, it reflects again in the same medium from where it came. So we can say that means light is the reflection of light is the phenomena of bouncing back. That means going back from where it came. One more thing, it doesn't mean and doesn't require that means कि only mirrors can reflect the light. Every surface and every body surface, or we can say the surface of every body which have that means real surface can reflect the light. It depends on the nature of the surface how much light is will reflect. That means the process of reflection will occur at every surface, but the amount of reflection of light will depend on the nature of the surface. According to that, we divide the reflection of light in two categories. One, regular reflection, or we can say specular reflection. Second, irregular reflection or diffuse reflection. To understand regular reflection, it's easy to understand that if the surface is smooth and well polished, that means surface should be optically smooth. Optically smooth, that means it should be smooth for light. So the light ray which strike, the light rays which strike on the polished surface. So in this manner, if the incident rays, if the all incident rays are parallel to each other, so we are seeing these incident rays are parallel to each other. After striking on the smooth surface, they reflect parallelly. Okay, that means the incident rays are parallel to each other and reflected rays are also parallel to each other. So then this type of reflection is known as regular reflection. So to understand regular reflection, what we have to understand, the incident rays or beam of incident rays should be parallel to each other and the beam of reflected rays should also be parallel to each other. Second thing, irregular reflection. In this manner, if surface is rough or not that much sufficient smooth, so if the parallel rays falling on the rough surface, they reflect in any direction. That means in this way, incident rays are parallel to each other, but reflected rays will not be parallel to each other. See, this is the reflected ray and this is also reflected ray and they are reflecting in different directions. So this type of reflection is known as irregular reflection. But you must understand and you must know that irregular reflection is more important than the regular reflection. General viewing perception or general appearance of the things uh, that means happens just because of irregular reflection. That means we are seeing the things around us just because of irregular reflection. Suppose a regular reflection will occur at every surface, we will unable to adjust that much amount of light and we cannot see the object nicely without helping of any other device. Hope you understood that means general appearance or general things and general appearance of the things based on the diffuse reflection. Just because of diffuse reflection, we are able to see the things around us. Now we'll go ahead. So now I'm showing with the help of an animation. See, this surface is there and light ray is coming in this manner. And after striking on this surface of the object, it will reflect back along the same, so in the same medium from where it came. Called of After that, we'll learn about the laws of reflection of light. Laws of reflection of light says we already discussed these laws in your previous classes. So first law says angle of incidence is equal to angle of reflection. That means angle between incident ray. This is incident ray and this is normal. This angle is usually denoted by I. And angle between reflected ray and normal is known as angle of reflection. These two are always equal in magnitude. So first law of reflection says that angle of incidence is equal to angle of reflection. Now second law, the incident ray, now we are seeing incident ray, this is incident ray and this is reflected ray, and normal at the point of incidence all lie in the same plane. That means they are in the same plane. We are observing light ray which is coming along this green ray and it is reflecting back in the same medium from where it came on after striking on the plane mirror. So hope so you understood both the laws nicely. Now these laws are applicable to all types of reflecting surfaces, including spherical surfaces. That means, as we discuss these laws will be applicable for each and every surface that can reflect the light. Objects is nothing else. Objects can be anything which gives out light rays, either its own or reflected by it. That means, any object is giving out the light. Light can be its own or it may be, and that means reflected light from other objects. So objects that means which can gives out the light in case of physics only. Now see, I wrote the definition with respect to physics subject only because object can be defined in by other way, but here we are understanding in the ray optics with spatial optics, so we are defining the things accordingly. Now objects also categorized in two ways. One is a luminous object. Luminous object that means the object which can emit the objects which can emits their own light. That means they have their own light, like sun, other stars, electric bulb, tube light. These are the luminous objects. That means they can emit their own light. Non-luminous object that means they do not emit the light themselves. That means they reflect the light or scatter the light falling on it. That means if light is falling on them and they are reflecting the light, so this type of object are known as non-luminous object. That means they don't have their own light. Now next topic is image. So images we learn, that means images is an optical appearance that when we click the photo, so we say the image is not good. Sometimes it is very good. So what does it mean? That means it's an optical appearance. Optical appearance, and it happens just because of intersection of light rays which are coming from particular object after reflection or refraction. They meet at a point, and this point will appear in some particular way. So this optical appearance is known as an image. Image also divided in two ways, real image and virtual image. The real image, that means the image which can be obtained on the screen, that means we can obtain the screen, is known as real image. In the cinema hall, we see the images of actors and actress on the screen. So we the image on the cinema screen is an example of real images. I hope you're understanding real images. That means the images which can be print on that can be obtained on the screen. Virtual image, that means the image which cannot be obtained on the screen. That means that we can see only and we can just feel it and we can just see it, but we cannot obtain the screen. And on the screen, is known as virtual image. As we see our face in the morning when we go to school, plane mirror shows the virtual image of our face. Hope you're understanding. Our next topic is lateral inversion. As we see in ourselves in the morning, or we can see ourselves in any time in the front in the plane mirror, we observe and we feel that our right portion of our body looks left side in the image and right side of the body looks right side in the image. That means our right becomes left and our left become right in the image. This is called lateral inversion. It happens or it the phenomena of lateral inversion is due to the reflection of light. You can see example here. The person is holding the things in this hand, but he has seen that the things is coming in other hand. That means it is becoming literally inverted. Now we learn about the characteristics of images formed by a plane mirror. We learn about the images formed by the plane mirror. Now first concept of images formed by plane mirror. The image of real object is always virtual. If we are keeping any real object in front of the real in the front of mirror, the image will be virtual. Such an image cannot be taken on the screen. Not take this type of image on the screen. The image formed by a plane mirror is always erect. That means the image will be erect as we are keeping the object in same manner. You will find the image in the mirror. The size of the image in the plane mirror is always same as the size of the object. That means the height of the object and height of the image will be same as the looks. That means there will not be any variation in the height of object and height of the image. The image formed in the plane mirror is as far behind the mirror as the object is in front of the mirror. That means if you are standing 1 meter away from the mirror, in front of the mirror, your image will be 1 meter behind the mirror. So mirror will be the midpoint between you and your image. I hope you're understanding. That means the image will be as far as you are standing in front of the mirror. That means mirror will be the midpoint of your image and your object or yourself. The image formed in plane mirror is literally inverted. We already discussed this point. That means the things of object in left side will appear right side in the image, and the things in the left side of the object will appear in right side in the image. That means the left will become right and right will become left. Now we learn about the spherical mirror. Spherical mirror, that means it is looking by name itself, that means spherical, that means the part of a sphere. If we are taking any part of a hollow sphere of glass and we are polishing either from outside or from inside, we will get a mirror. This type of mirror is known as spherical mirror. Why we are saying it is spherical mirror? Because it is a part of a sphere of hollow glass sphere. Okay. These spherical mirrors are also further divided into two categories. First is concave mirror and second is convex mirror. A concave mirror, if we are taking any part of a sphere and we are polishing from outside and the light is reflecting from inside, that means curved inward surface. That means suppose this is the spherical mirror, part of sphere, and we are polishing from outside and light is reflecting from inside. That means curved inward. This is the reflecting surface in this manner. That this type of mirror is known as concave mirror. I hope you're understanding concave mirror. That means when light is reflected from the light is reflected from the surface which is curved inward. Convex mirror, when we are taking any parts of a part of a sphere and we are polishing from inside, light is reflecting from outer surface. So this outer surface, that means bulging outwards, bulging outwards or out means curved outward. This type of mirror is known as convex mirror. Now we will learn about some terms related to spherical mirror. First term, center of curvature. As we are observing, these two mirrors are the part of a sphere, so the sphere will have some radius. So that radius of sphere will be known as the radius of curvature for this mirror. That means we can say the center of curvature of a spherical mirror is the center of the hollow sphere of glass of which spherical mirror is a part. That means we took these two mirrors from the sphere, so sphere will have center and radius. Both the things sphere will have both the things center and radius. So center of the sphere will be known as center of curvature for the mirror, and radius of the curvature is known as and that means radius of the sphere will be known as radius of curvature for the mirror. So we understood both the things. After that, we have a mirror, and suppose we are taking any midpoint on the mirror. This midpoint is known as pole of the mirror. It is denoted by capital P. As I explained radius of curvature earlier, so I hope you understood. Now, a line joining a line passing through the pole and center of curvature is known as principal axis. Okay, if we are drawing or if we are taking any line which is passing through or which passes through pole and center of curvature is known as principal axis. And see, we have this concave mirror, and this diameter of this concave mirror will be this one. So this diameter is known as aperture of the mirror. That means diameter of the reflecting surface. I hope you understood well this much. Now we can see two space I took, and suppose we are taking any part in this sphere. What did I do? I polished from inside, so reflecting surface will be this outward, no? Outward surface, or this bulging outward surface. It will reflect the light and diverge the light rays, so it is a convex mirror. I hope you understood well. Now next topic will be principal focus of a spherical mirror. If we are taking any point or a point on principal axis at which the light rays which are coming parallel to principal axis, after reflection they are converging, or they are converges, or they converge at a particular point. That point of convergence is known as principal focus of concave mirror. So we can say simply, in case of concave mirror, if light rays are coming parallel to principal axis, after reflection they will meet at a point. This point is known as principal focus. In case of concave mirror, principal focus will be real. So because whatever with the things written on this point we can obtain on the screen. So we can see the focus of concave mirror is real, and this mirror is converging the light ray, so it is also known as converging mirror. Okay, I hope you're understanding. Same thing happens as that opposite thing happens in the case of convex mirror. Light rays which are coming parallel to principal axis, after reflection they diverge, or it that means we observe, that means it looks, that means these rays are diverging from this point. So this point of divergence is known as principal focus for convex mirror. So we can say in short, if light rays which are coming parallel to principal axis, after reflection from the convex mirror, they appears to diverge from a point. That point is known as principal focus convex mirror. Convex mirror diverges the light rays, so it is also known as diverging mirror. Now we can see in this way I polished the mirror from inside, so light reflection happening on this surface. So this is known as convex mirror, and I polished outside and reflection happening from the inner surface. So it is known as concave mirror. I hope this is convex mirror and this is concave mirror. I hope you understood well. Now focal length, the distance between principal focus and pole. Okay, the distance between principal focus and pole is known as focal length. And there is a relation between focal length and radius of curvature. That means half of the radius of curvature is always equal to focal length of the mirror. So half of the radius of curvature is equal to focal length. And in other words, we can say twice of the focal length is equals to radius of curvature. Now we learn about the rules for obtaining images formed by spherical mirrors. So there are four rules to obtain the images from the spherical mirrors. First rule says, if light rays which is coming parallel to principal axis, see this is the principal axis and this light ray is coming parallel to principal axis, after reflection from concave mirror, it will pass through focus. But in case of convex mirror, after reflection from convex mirror, it appears to diverge from focus. That means it will look, that means it is diverging from the focus. Okay, I hope you understood first law. Second law, if light rays is passing through the focus in case of concave mirror, because concave mirror has a real focus, so light can pass through it. Light rays passing through principal focus after reflection from the mirror, it will emerge parallel to principal axis. But in case of convex mirror, the light ray which is coming in the direction of focus, or it is directed towards the focus. See, this is the focus and light rays directing or coming in the direction of focus. After reflection, it will become or it will emerge parallel to principal axis. I hope you understood this method also. Now we'll see some animation to understand. See, I took rule 1, this is rule 1, this is rule 2, and I took concave mirror and this is convex mirror, and we'll learn both the rule 1 and rule 2 with the help of little animation. See the light rays, you can see that this is the incident ray which is coming parallel to principal axis. Rule says after reflection from the mirror, it will pass through the focus. I hope you understood. This light rays was parallel to principal axis. See, it came parallel to principal axis, and after reflection from the mirror, it passes through the focus. And now, second, in case of convex mirror, light rays is coming parallel to principal axis. After reflection from the mirror, it will appear to diverge from the focus. That means it appears to diverge from the focus. See here, focus. Next one is now see light ray which is passing through the focus. First is it passing through focus. After reflection, it will become parallel to principal axis from the mirror. I hope you are understanding. And now see in last case, light rays which is directed towards the focus. See direction of light rays, incident ray is in the direction of focus. So after reflection, it will reflect parallel to principal axis. See the direction of, see it was direction. I hope you are understanding. It was the direction of focus towards the focus or in the direction of focus. I hope you're understanding. Incident rays, reflected rays, incident ray, and reflected ray. I hope you understood with the help of this little animation. It is easy to understand. I created with the help of PowerPoint so you can understand well. Now, third and fourth rule. Third rule says that if a light ray is coming in the direction of center of curvature, or it is passing through the center of curvature. Okay, in case of concave mirror, it will pass through the center of curvature, but in case of convex mirror, it will come in the direction of center of curvature. That means it is directed towards the center of curvature. So we are observing in case 1, it is passing really through the center of curvature. See, this is center of curvature, but it is coming in the direction of center of curvature in case of convex mirror. After reflection from the mirror, it will reflect back along the same path from where it came. That means as it came with the incident ray came in the same path, and according to that path, the reflected ray will also go by the same way. And fourth rule says that if light rays for light rays falling obliquely, that means not perpendicular, not parallel. It will reflect obliquely. That means at which angle, at the angle at which it is falling, by the same angle it will reflect. That means angle of incidence will be equal to angle of reflection. I hope you understood well these two laws. Now we'll see some animations to understand this one. See, you can see the mirrors. These two are concave mirror and these two are convex mirror, and pole, focus, and curvature. So I'm showing first light rays which are coming, which is passing through the center of curvature. It will reflect along the same path. That means it is reflecting from where it came. Okay, as it comes, it will go along the same way. What we are observing, so in same way, it is coming in the direction of center of curvature. See, it is coming in the direction of center of curvature. So it must also reflect along the same path. So what we are observing, light is falling on the angle of incidence. It will reflect by the angle of reflection of the same amount. With this way, the angle of incidence will be equal to angle of reflection. Here also we can see in the case of convex mirror, it came in this manner, it is going in this manner. I hope you are understanding. So I didn't show the reflected ray in this diagram, so I'm showing, see, incident ray, incident ray, all are incident rays. Now reflected ray is coming, reflected ray, here also reflected ray, and now that reflected ray at the end. I hope you understood reflected ray and you saw the things nicely. Now we'll learn about the formation of different types of images via concave mirror. Very important topic and very easy concept. So there are six possible cases and there are six positions at which we can keep the object and we can obtain the images with the help of concave mirror. First concept says that if we are keeping the object between focus, see this is focus and pole, so the image will be behind the mirror. In this case, concave mirror forms a virtual image. So the image will be erect behind the mirror and larger than the object. So you have to keep these 3 points. If we are keeping the object over here, light ray which are coming in the direction, this light ray is going in the direction of center of curvature, so it will reflect back along the same path. And the second ray which is following the fourth rule, angle of incidence equal to angle of reflection. These two light rays will never meet at each other ahead, so we extended back and we found the image backside of the mirror behind the mirror. Now you can see the first and second and that means case. I'll skip the second case. I will explain over here also, no problem. You can see what we are observing. The object is kept between focus. See, this is a focus. Here, focus is there, and this is center of curvature. And this is so light and object is kept between focus and pole. So first rule is light is falling along the along the center of, and that means along the center of curvature. So we can see it will reflect along the same path. It will reflect along the same path. See, it is reflecting along the same path because it is falling along the center of curvature in that the direction of center of curvature. It reflected back along the same path. Now second ray, which is falling obliquely, it will reflect obliquely. These two light rays will never meet each other, so we have to extend backside them. We'll extend backside, and we after extension we'll see this. This is the position of extended ray of first ray, and now this is the position and this is the way of extension of second ray. We'll find the image of this AB object behind the mirror. Now you can see very nicely, you can see coming in the form of image. We are observing automatically the size of the image is larger than the object and it is erect also. So hope so you understood well. Now see the second case when object is kept at the focus, directly at the focus. Light ray which is falling in the along the direction of center of curvature, so it will reflect back. See, it is reflecting back as it goes. Okay, as it goes, it is reflecting back. So we are observing first rule and second rule also. And now, if after observing, we are observing that means if light ray which is coming parallel to pencil axis after reflection, it will pass through the focus. So it is passing through the focus. These two light rays are parallel to each other, so they will not meet to each other. So image will be at the infinity, and the nature of the image will be real and inverted and very large and very large as compared to the. I hope you understood well. This is A dash and B dash is the image of AB. This now rule number 3 and 4. Sorry, case number 3 and 4. Case number 3 says when object is we are keeping the object between focus. This is the focus and this is center of curvature. We are keeping the object between focus and center of curvature. So image will be forming or image will form behind the center of curvature. You can see first law. light ray which is coming parallel to principal axis. See, this is a light ray which is coming parallel to principal axis. After reflection, it will pass through the focus, and light ray which is coming in the direction of center of curvature. See, this light ray is coming in the direction of center of curvature. It will reflect back along the same path. So we'll find here A dash B dash is the new position of this image of this object. In case number 4, when we kept the, see here, in case number 3 first, I want to explain once again. Means the position of image will be behind, or sorry, beyond the center of curvature. The nature will be real and inverted, and the size of the image will be larger than the case number 4. When we are keeping the object at the center of curvature, image will also be formed at the center of curvature. So in this manner, or in this case, the size of the image will be exactly equal as the size of the object. And second thing, at the that means the size I already described, and the nature of the image will be real and inverted, and position will be at the center of curvature. After this, you will see some animation so that you can understand well these two cases also. I hope you understood this much. In case number 3, and this is case number 4, I kept the object between focus. See, this is the focus, and this is the center of curvature, and this AD is the object which is kept between the focus and center of curvature. Now we'll see light rays is falling in the direction of center of curvature, so it will reflect back along the same path as it came. So it is passing back along the same path. I hope you are understanding. It will reflect back along the same path. And light ray which is coming parallel to principal axis, after reflection it will pass through the focus. See, these two light rays are meeting at a point. See, when you will draw these all diagram on the scales, automatically you will find that means the image will be larger than the object. See here, I took everything on the scale, so it is coming automatically. That means these are not fake diagram. That means these all are on the proper scale, so it is coming automatically. We are seeing the small size of the object, but we'll see the large size of the image. See, this is the large size of the image. We are observing size of the image is larger than the size of. Now case number 4. I kept the object at the center of curvature. See, this is the center of curvature, and this is the focus, and A and B is the name of the image. That is the object. Light rays which are coming parallel to principal axis from the top of the object. After reflection, it will pass through the focus. See, it is passing through the focus, and light ray which are coming, which are passing through the focus first. They are, see, this red light is incident light, and this red light also incident light, and they are this ray is passing through the focus first. After reflection, it will become parallel to principal axis. These two light rays are meeting at this point, so image will be forming at this point. See, we first found that image is formed. The size of the image is exactly same as the size of the object. I hope you understood well. Now A dash and B dash is the name of the image, and this image is of object AB. Hence, we are seeing the object and image are of the same size, and the nature of the image will be real and inverted, and the size of the image will be exactly same as the size of the object. Now, fifth case, we are observing in fifth case, object is kept beyond the center of curvature. If we are keeping the object beyond the center of curvature, image will form between focus and center of curvature. The size of the image will be smaller than the size of the object, and image will be real and inverted. So see the procedure to forming the image. The light ray which are coming parallel to principal axis, after reflection, it will pass through the focus, and the light ray which are coming through the center of curvature, it will reflect along the same path. Hope so you are understanding. Case when object is kept at the infinity, in this case we consider that all the light rays will come parallel to each other, and after reflection from the mirror they will converge at the point. This point of conversion will be the point image of the object which is kept at the infinity. So in this manner the image will be The position of image will be at the focus, and the size of the image will be very small, very diminished, but nature will be real and inverted. Now we'll see some animation also. See, this is the fifth case. I took this nail between center of curvature and infinity. That means, or we can say beyond the center of curvature. And now see light rays. Light rays is falling perpendicularly on the so that means parallel to the principal axis on the mirror. That means the light rays which is coming parallel to principal axis. After reflection, it will pass through the focus. See, after reflection, it is passing through the focus, and second light ray which is coming and falling on the mirror perpendicularly, and it is coming through the center of curvature, so it will reflect back along the same path. It is reflecting along the same path. So we are observing that these two rays are meeting at this point. So this point of intersection will be the image of object AB. So automatically we are observing, see, the size of the image is lesser than the size of the object. Automatically it comes if we are drawing the things and if you are drawing things on the proper scale. I hope you understood this much well. Now we'll go in last case, that is in this manner the object is sorry the in this manner the object is kept at the infinity. We are observing this object is kept at the infinity. So light rays will come parallel to each other or and parallel to principal axis. So these light rays are coming parallel to each other and parallel to principal axis. After reflection from the mirror, they will converge at the point. Point is known as the image. This point, that means the image of this object will be in the point shape and it is very diminished. So we can say the object which is kept at infinity, very diminished image will find out at the focus of the mirror. I hope you understood well everything. So now we'll discuss about the uses of concave mirror. Concave mirrors are commonly used in torches, searchlight, and vehicles headlights to get powerful parallel beams of light. That means we use these mirrors to get the powerful parallel beams of light. Concave mirrors are also used as shaving mirrors to see the larger image of face so that we can do the shavings easily without any injury. Dentists also use this concave mirror to see the large images of teeth of the patients, and some doctors are also using these concave mirror as a head mirrors to concentrate the light and on particular parts of the body which is coming from the lamp. That means to concentrate the light which is coming from the lamp, we use as a reflector, and we used to wear that mirror at the head, so they are known as head mirrors. Okay, and nowadays we are observing concave shape of dish TVs, that means dishes. The dish also concave dishes are also used in TV dish antenna to receive TV signals from the distant satellite communication satellites. Large concave mirrors are used to concentrate sunlight in to produce heat in solar furnaces. In solar furnaces, we use concave mirror to concentrate the light to produce a large amount of heat. Now we are observing. Now we are observing one more thing. One more thing. Sorry, my dear students, I wrote by mistake here at 6. And so only two cases will be there. Now we learn formation of different types of images by convex mirror. Convex mirror will form the image between focus and pole, always irrespective the position of the object. That means if you are keeping the object between pole to infinity, the image will form between pole and focus in the case of convex mirror. So we have only two cases in convex mirror. When first case, when object is placed between pole and infinity, so in this manner the image will form between pole and focus. The image will be virtual and erect and is smaller than the object. We are observing this object is kept between pole and infinity. Now, first light ray which is coming parallel to principal axis. After reflection, it will appears to diverge from the focus, and the second ray which is coming in the direction of center of curvature, so it will reflect along the same path. So after extending, these two rays will find the image of the object a dash b dash over here. This is the image of object AB. So the size of the image will be diminished, that means very small as compared to the object. It will be virtual and erect. Now, second case, when object is kept at the infinity, the light rays which are coming parallel to principal axis, after reflection, they will appear to diverge from the focus. So this at this point, the image will form at the point, and image will be of point size, very diminished, and the nature of the image will be virtual and erect, very much smaller than object. I hope understood. So we'll see some animations also. See, I took and I kept the object between pole and infinity, and light rays which are coming parallel to principal axis. After reflection, it will appear to diverge from the focus. It is looking, that means it is reflecting, and it is looking that it is diverges, or it diverges. It is diverging from the focus. And second ray which is coming in the direction of center of curvature, after reflection, it will pass or it will reflect back along the same path as it came. Okay, so we are observing these two light rays are meeting at this point. So this point is then at this point we'll get the image of object A dash AB as A dash B dash. See, the image is very small and very, that means small in size and very diminished. So we can say that means concave convex mirror always form convex. See, one very important thing, convex mirror always form virtual image of real object. Now, second case, light rays which are coming parallel to principal axis, after reflection, they will appear to diverge from the focus. So, find out that means the image of on this object will be at focus, and the size of image will be point size, and it will be virtual and erect. I hope you understood well. So now we learn about the uses of convex mirror. The wide use of convex mirror is as a rear view mirror in the vehicles. That means these mirrors are fitted on the side of the vehicle, enabling the driver to see traffic behind him and her to facilitate the safe driving. That means driver can do the safe driving, so they have to see backside of the vehicle also. So we used to put side mirror as a convex mirror. They provide the and the virtual direct image of object behind them so that we can perceive them as they are appear. That means otherwise what will happen in the case of concave mirror, we will see the opposite or inverted image, so that will be confusing for the drivers. So we used um, convex mirror as a rear view mirror so that they provide diminished and direct image of the all of the objects, and they have a wider field of view. That means they cover the wide field as compared to plane mirror. So we, because they are curved outward, so we use convex mirror as a side view mirror. Now I wrote some index question also, solution of their index question. So I think you can see the index question. I wrote the solution, so there is no need to explain. I think you will learn because we already discussed these all concepts. So please see, and the principal focus of concave mirror. We already discussed this question, and we already discussed what is the relationship between focal length and radius of curvature. So we can find the focal length because radius of curvature is given as 20 centimeter. And next question, name a mirror that can give an erect and enlarged image of an object. That means we know concave mirror can give erect image in one case, that was first case. If we are keeping the object between focus and pole, we'll get enlarged image and erect image of an object. And we already discussed just now why do we prefer a convex mirror as a rear view mirror in vehicles. And now next topic is Mirror formula, that means this is the relationship between distance of object, it is denoted by small u, distance of image, it is denoted by small v, and focal length of spherical mirror, it is denoted by small f. And there is a relationship between these all three quantities, which is known as mirror formula. And it is written as 1 upon f is equals to 1 upon v plus 1 upon u. Okay, I hope you understood this much. Now, next point and next topic is magnification. Magnification by a spherical mirror gives the relative extent to the image of object is magnified. That means simple language you can understand. It is the comparison between image and object. That means at what level, at what extent image is magnified or image is diminished. Okay, so we can say that means this is the comparison at what ratio the image is increasing or at what ratio image is decreasing. So it is given as height of the image upon height of the object. That means size of the image upon size of the object is the magnification produced by spherical mirror. It has another relationship. It is given as minus v upon u. V is distance of image and u is distance of object. So this is also a relation. We'll find we'll find the derivation of this spherical mirror, but this derivation will be somewhat difficult to you because you are unable to understand now um, this similarity of triangle. If you completed chapter number 6 in mathematics, then you will come to know. Otherwise it will be quite difficult, but I want to explain, then later on you can revise it so that you can understand. So here I took one case when object is kept beyond the center of curvature. You are seeing this is the spherical mirror. I took concave mirror and I kept the object beyond the center of curvature. So I drew the diagram. We already discussed these all things in previous cases. So we are observing here. This is A, B, an object, A dash, B dash image, F focus, this is focus, and this C is center of curvature. I hope you are knowing these all things. Now I want to take this triangle ABC and this triangle A dash, B dash and C. So I'm taking these two triangle and I'm observing that object is always kept perpendicular to the principal axis and image also. So this is the right angle triangle. So we are observing angle ABC is equals to A dash B dash C. So what's the reason? Each right angle. And we are observing this angle is equal to this. These two are vertically opposite angles. If two angles are equal in a particular triangle will be similar to each other. So we can write this AB upon A dash B dash is equals to BC upon B dash C. That means this is the concept of similarity. Two triangles are similar, their sides are proportional. We got first equation. Similarly, we'll take other. Now, similarly, we'll take other two triangles. Which triangle? A dash, B dash, F, and Q, D, F. I took this point as Q. No? See, this point is Q only. Okay. So we'll find again this is 90 degree, and this is also 90 degree. And this is vertically opposite angle and this is also vertically opposite angle. So these two triangles are again similar. So I wrote again similarity concept, that means QD upon this perpendicular, here also perpendicular, A dash B dash is also perpendicular. So this is a perpendicular concept, A dash B dash equals to, here base is FD or DF, you can say DF is equals to DF upon B dash. You can find here I wrote this is okay. But we are observing this QD. See, this QD is exactly equal to this AB because it is forming rectangle. Opposite sides are equal. So I replace this QD as AB. And if aperture of mirror is small, so this B point will be very close to this point P. See, this point P will be here, pole will be over here. So this D point will be very close to this P. So I wrote DF is equals to, that means this DF distance will be approximately equal to PF. So I wrote here, so I replace this DE, so DF or this QD. Okay, after replacing, here we got in the place of QD, I wrote AB, in the place of DF, I wrote PF. Then we are observing one more thing. See this portion a dash ab upon a dash b dash and ab upon a dash b dash. These two are same, so we can remove them. So this is equals to this. I wrote this is equal to this. Now this BC, this portion BC, this is BC portion. So we can find this PB minus this PC. So we can find this BC portion. So I wrote this PB minus PC in the place of BC. Okay, and similarly again, if we want to place which one v dash c, this v dash c, so how this PC portion this much, and we'll remove this p dash b dash, so this b dash c will come. So I wrote PC minus p b dash, and now pf will be exactly same pf, so I'm not removing this pf. And now this b dash f, this b dash f will be p b dash minus pf, so we can replace this pb dash minus pf. Now we'll replace the values, and after replacing the values, see what will happen. Will happen, see here is pb, that means this p point and this b point, so it shows that means object kept at distance u. So in the place of pb we can write minus u, minus sign same. PC, that means this c is center of curvature, so it will be radius of curvature r, and upon this PC again minus radius of. I hope you are not, I think you are not understanding this my why I'm taking my negative sign, because we'll discuss the sign convention. So sign convention after that, afterward I will discuss the sign convention. Sorry to that means I forgot to discuss. I think I should discuss first these. No problem, you can understand later on. So I took this is P E as minus PB, that means B is PB, that means this is the object, sorry, image distance. Again here, this PF, this minus focal length, and this PB minus B, and this minus F. Okay, and after that we'll find minus Q same, and minus minus plus R, and this is minus R and plus B, as equals to minus F upon minus B plus. Okay, after that we learn. So I'll give you the concept. That means what was the things we found. Is we found here what was the things here, minus PB, that means minus P minus U was there, and it was plus R. We found that, and this was minus R, and plus V is equals to minus F upon minus V and plus F. Okay, and we know R equals to 2F. We can write as we know the concept, so we can replace R as 2F minus U and plus twice of F. Here also minus twice of F plus B is equals to minus F upon B minus and plus. After further solution, you will find the relation 1 by F equals to 1 by V plus 1 by U. In next class, we will learn about the sign convention. I hope you understood this much. So, sign after understanding the sign convention, you will come to know about the all. I hope you are understanding.